Effects. There's no test at the end, and you don't need to know anything going in. These videos are meant for rest, for reflection, or just for the background of a quiet moment. The topics are big, but we don't tackle them. We wander through them. Sometimes with answers, sometimes with questions, always slowly. Tonight, we're asking something a little strange. Something simple on the surface, but more complicated the longer you think about it. Do black holes have a limit, or can they just keep going forever? Swallowing everything they touch? Growing and growing without end? It's a question that doesn't need an immediate answer. It's something you can just carry for a while. Let it unfold slowly, like the night outside your window. Maybe you've thought about black holes before. Maybe just in passing. Maybe you've seen an article, a simulation, a headline. They're easy to imagine as monsters. Huge, powerful, dark things that pull everything in and let nothing out. That image, a cosmic predator, is both helpful and misleading. Black holes aren't alive. They don't think, but the idea of endless consumption does something to the human mind. It stirs up fear, curiosity, awe. So let's pause. What really is a black hole? Not just an invisible void, but a region of space-time where gravity is so intense that nothing, not even light, can escape. The edge of a black hole is called the event horizon. Once something crosses it, a particle, a photon, a spacecraft, it's gone, irretrievably. It adds to the mass of the black hole. This is how they grow. They feed, but not actively. When material gets close enough, stars, gas, dust, even other black holes, it's drawn in. As it spirals inward, it heats up, glows, sometimes outshining entire galaxies. And then, silence. The light vanishes. The object is no more. So back to the question. Is there a limit? Can black holes grow without end? On paper, yes. The more mass a black hole accumulates, the stronger its gravity becomes. The larger its event horizon grows. Theoretically, if it could keep feeding forever, it could become infinitely massive. But in practice, the universe has constraints. There's only so much matter nearby. Even in galaxies, black holes eventually run out of fuel. They can become dormant, quiet, waiting. And then there's time. Black holes aren't forever. Over unimaginable timescales, they evaporate through a process called Hawking radiation. Tiny leaks of energy, shrinking them ever so slowly. For a black hole the mass of our sun, this process takes longer than the current age of the universe. Many, many trillions of years. But the point is, they have an end. So no, black holes don't grow forever. They can become vast, but not infinite. They are powerful, but not unstoppable. And that, in a strange way, makes them even more fascinating. Because in a cosmos that often feels unknowable, they offer a paradox. Something that seems eternal, but isn't. Something that hides everything, yet reveals the deepest truths about space, time, and even reality itself. So, as you drift into sleep, or just into quiet thought, hold on to that question. Not to solve it, just to feel it, just to float in it. Like starlight that almost escapes, but doesn't.